Find the coordinates of the turning point of this graph. This is a quadratic, and it might look a little bit like this, and we're being asked to work out the coordinates here. How do we do that? Well, the method that is being expected is to complete the square. And we can do this by taking x squared plus 6x and writing it as x plus 3 all squared, and then minusing 9 from it. Let me backtrack and explain where that's come from. So essentially, I've got x here, and then I've got x here, and 6. That would give me x squared plus 6x. Forget the 17 for the moment. What I can do is I can split this into 2. So this is now 3 and 3. And I can move this little bit around so it's like this. So that bit's gone. So now I've got a 3 down here and a 3 down here. Because if I bring it together, I've essentially made a square. X plus 3 all squared would be the area. Except I've got this missing bit that I don't actually have. So I need to minus the area of that, which is 9. I just did that really quickly because you can learn over time to just have whatever's in front of the x, and then you minus whatever this thing is squared. It will always be that. In my case, I still need to add the 17, but I'm well on my way. You might be thinking, like, how does this give the turning point? I'll show you in a second. So that's going to give me plus 8. Okay, and I put it in completed square form. Right, this allows you to work out the turning point, because now I've got something squared, it's always greater or equal to 0. I can't get a negative from this thing here. And therefore, the function as a whole is always greater or equal to 8. That is the smallest it could possibly be when this thing is 0. So my minimum value is going to be 8 here. I mean, it's actually not going to be up here, it's going to be up here. But I just used the idea to illustrate it. It's going to be positive. Now, when is it actually going to equal 8? It's going to be when this thing is actually equal to 0. So when x plus 3 squared is equal to 0, when x plus 3 is 0, same thing. And so x is going to be minus 3. And to summarize, if you're ever asked to find the turning point of a quadratic, you can complete the square using the steps I've said, and then you can take the number by itself. That will be the minimum or the maximum. And then whatever's here, you just take the negative of it, and that will give you the x coordinate of the minimum or the maximum.